Hello friends, my name is Laksh. In this video we will learn about pd.read CSV. You will see how you can optimize space and time while reading CSV only. For those who are very new to Pandas, please be rest assured I'll make sure no one is left behind. Let's get back to the screen. CSV stands for comma separated values. Extension of this kind of file is .csv. Some of the examples of this kind of file is fruit.csv, book.csv. You can notice that these files are ending with .csv. Here also .csv. So please keep in your mind. These are some CSV files. Let me open properties of any one of the file. So here you can see .csv right here, which signifies that this file is a CSV file. At the same time, you can see the location of this file here. Let me open any one of the file. Right click, open with Notepad. This is how a CSV file look like. So this is a screenshot of the same CSV file. In this file, this is what we call one field. This is another field. Similarly, this is another field and this is another field. Likewise, this is one field, this is another, and so on. And this is one line. This is another line. This is another line. And it goes on. In this CSV file, you can see that fields are separated by a comma. That's why it is called a comma separated values. All the fields are separated by comma. And all the rows are separated by new line, right? When we read this file in Pandas, it looks something like this. Is it necessary that fields will always be separated by comma and line will be separated by new line? No, it is not. Let me zoom in a little bit. This is the same example. In this, you can see this is the first row and this is line terminator. This is another row and this is line terminator. It goes so on, and these fields are here separated by comma. These two fields are separated by comma, right? In this example, this is field separator and line separator is new line. Here we have another example. In this example, this is field separator and this is what we call line terminator. This is also field separator, field separator, field separator. This is line terminator at the rate. I hope it is clear. While reading CSV, the first thing what we need to know is the path of the file. So how to find the path of this file? So you can right click on any of the file. You can click on properties. Here you will find the path or location. Syntax of reading file is pd.read CSV path followed by name of the file. So let's do one practical. We will first import NumPy and Pandas. We have copied the name of the file. We'll just paste it followed by /. This backward slash needs to be removed by /. So this is the complete path. Fruit.csv. So when we are running this, we are getting the same output that we were seeing some time back, right? In fruit.csv, let me open it parallelly. These fields are separated by comma and every line is separated by new line, right? This is the default behavior. What if we change some of the things, like let's replace comma with star. Replace comma with star or asterisk. Replace all. We will just save this file, Ctrl S. Now if we try to read this file, we are getting something weird, right? This is not what we expect. What we expect? We expect this output, this here. So in this case, what we need to tell pandas? We need to tell pandas that separator is asterisk or star. Separator equal to star. Now let's run this and we will see the magic. Now let's modify the notepad once again. Now what I want, that line separator should be at the rate. This star is a field separator. This is a field separator, and this is a line separator. This is also a line separator. So at the rate is a line separator and star is a field separator. Let's save this notepad also. Control S. Now let's try to run this. So again something weird we are getting. In this case, we need to tell pandas that no, new line is not the line terminator. Something called at the rate is a line terminator. So how we will do this? We will pass another parameter called line terminator. Control V. Line terminator equal to at the rate. Now when we read this, see the magic. Okay, y slash and slash r. Something extra characters are copy pasted here, I guess. Let me delete it. Control S. Let me run again. I hope it is clear. Another name of separator is delimiter. So when we replace this separator with delimiter, it still works the same. In last video, we have seen that here we have to mention complete path. But there is an exception. When the Python file in which you are writing the code and the CSV file are in the same folder, then you don't have to mention complete path. Only file name will be sufficient. You can remove this redundant part. Here in this example, this is the name of the file in which we are writing code. The name is untitled and the file which we are reading is fruit.csv. So both are in the same folder. You can see here in pandas read folder, fruit.csv here and untitled here. Both are in same folder. Hence, it is not necessary for us to mention complete path. Only file name will be sufficient. So let's remove the extra part and try running it. You can see it worked very well. Now let's learn about headers. I have altered this CSV file. I have added these 3 extra lines. So you can see that this data does not make any sense. This is extra lines and the header is here. This is 0th line, this is first line, this is second line and this is third line. So you can see header is on third line and above all that these lines are of no use. So in this case we have to tell pandas that header is on third line. Ignore the lines above header. So that's what we are doing here. We are mentioning header is equal to 3. So let's run it. This file is not saved. We'll save this CSV file and run this code again. You can see by default it is going to the third line. It is making this line header and other lines are data. It is also possible that your file does not have header only. Okay. So in this file you can see there is no header, only data is there, right? So in this case we have to tell pandas that there is no header in the CSV file. So the same thing can be done by mentioning header equal to none. Means there is no header in the file. Let's run it. When we are running with header equal to none, what is happening? Pandas is by default assigning some headers. These 0, 1, 2, 3 are headers. This 0, 1, 2, 3 as header is really misleading. It is not making any sense. So there should be some way in which we can tell that whatever names we are mentioning should be the header, not 0, 1, 2, 3. So there is one way. So this is the solution. Here you can see that header equal to none. It tells that there is no header in the CSV file. And names is equal to header tells that whatever the values in the header is the header of the data frame. What is stored in this header? This header is defined here. So you can see name1 is the first header, fruit1 is the second header. Similarly, quantity is the third header. The same header you are passing it here, right, in names, hence it is reflecting in the data frame. If you change any value like name1, if you change to name2 and run it, it will reflect in the data frame also. If you don't want to make this variable, you want to skip this variable, so there is any solution. Let me comment this line first and copy this list and assign it to the names. It will do the same thing. Let me run it again. Output has not changed. Here any value if you want to change, let's say name2 you want to change it to name3 and fruit1 you want to change it to fruit3. You will run it. The changes will reflect here, name3 and fruit3. In the right hand side, you can see we have opened the same fruit.csv file in Excel. Let's read this CSV file. Control enter to run. Here you can see in this data frame we have 1, 2, 3 and 4 columns. But sometime for your analysis you don't need all these 4 columns. Let's say for your analysis you need only name column and quantity column. So how to read only these 2 columns? For that there is one parameter called use calls. What you will do? You will first define one list with the names of columns that you want to read. You will store this list in some variable. When you pass this variable to use columns, it will read only those 2 columns. Let's run it. Control enter. You can see it is running only those 2 columns. There is another way to achieve the same by passing index. Let's suppose you want to read 0 index, first index and second index. So this is name is 0 index, fruit is first index and quantity is second index. So what you need to do? You need to pass this list to use calls. When we run it, we will read only those columns. Let's suppose you don't want to create one extra variable called column. Then what you can do? You can directly pass this list into use columns. So in this case also it will read only name and quantity. Let's run this. So it is reading only these 2 columns. But is there any advantage of using this? Yes, there is one. It helps us in saving memory. If you are reading all the columns, let's find out how much memory it is utilizing. When we run pd.readcsv.info, it will show the number of bytes it is using. But what is the bytes it is using when it is reading only 2 columns? Let's find out that also. Control enter to run. So when we are reading only 2 columns, it is taking approximately 244 bytes. But with 4 columns, it is taking 365 bytes. Definitely, we are utilizing less memory when we are reading less number of columns. When we check the information of fruit.csv, we will find that data type of quantity column is int64. As we already know, int64 is used to store very large numbers. But in our data, quantity does not have very large number. These are small numbers only. So this can be accommodated in int16 also. So how to do that? We can do that with the help of dtype parameter. Dtype takes input as a dictionary. In this, key is column name and its data type is value. When we check the information of this, you will find that data type of quantity column is int16 and int60 takes less memory as compared to int64. Hence you can see that when data type is int16, it is taking 314 byte, but when data type is int64, it is taking 356 byte, which is greater than that of 314. So dtype helps us in saving memory also. Before we explain another example of dtype, let me explain what is categorical data. Categorical data helps us dividing things into groups. For example, human can be divided into male and female, hence it is a categorical data. Similarly, your performance can either be good, better or bad, hence it is a categorical data. Similarly, statements made by you can either be true or false, hence this is also categorical data. I hope you understood what is categorical data. Let's see one more example. In this data frame, the column category has two things. It is either fruit or vegetable. This category is dividing product into two categories, which is either fruit or vegetable. But data type of category column is string or object in terms of pandas. You already know large string takes more memory. So how Panda will handle this? Panda will convert this fruit into 0, this fruit into 0, this vegetable into 1, again fruit 0, vegetable 1, 1, 1, 1 and so on. And somewhere other it will store 0 means fruit and 1 means vegetable. This is called efficient encoding. And this 0 and 1 can be stored in int 8 also, which takes very less memory as compared to these large strings. Hence, converting this category from string to category data type seems to be a good decision. Let's do practical for the same. So this sales.csv we are reading it and storing in data frame 5, df5. Similarly, the same data we are storing in df6 also, but here the difference is category column is of category data type. Let's check the info of both. In df5, category column is object and it is taking 1.5 KB. But in df6, data type of category column is category. And due to this, it is taking less memory, 1.2 KB, which is less than that of 1.5 KB. Now, when you read sales.csv, you will notice that data type of costly column is string. In Pandas, we call it object. But if we want to convert all the yes into true values and all the no's into false values, how is it possible? It is possible with the help of these two parameters, that is true values and false values. In true values, we pass all the list of values which needs to be converted into true values. Similarly, in false values, we pass list of all the values which needs to be converted into false values. So if we run this, you will notice that all the yes are converted into true values. This yes is converted into true here. Similarly, second yes, this small yes, this is equal to this yes. Again, that is converting into true. Similarly, all the no's, if you will notice, this small no and capital N small o will be converted into false. But what is the advantage of using these true values and false values? One of the advantage is that this costly column becomes bool and you will have flexibility to perform boolean operation on this column. Let's check this also. Since it is a bool data type, you can see, and bool data types utilizes less memory, so here it is utilizing 330 bytes. But similarly, if we check for sales, you will notice here costly column is object. Object utilizes little more memory than that of bool. That's what it is reflecting here. It is utilizing 372, which is greater than 330. Hence, true values and false values together helps in reducing the memory utilization also. But I have one question. Question is, will we be able to use only true values or only false values at a time? So will it work? Let's try that. Let's remove false values, control enter. When we are running this, so we are not seeing that yes value to be converted into true. Why so? Because since we are not using false values, these no's are not converting into false. So this data type of this no is string only. This no is also a string, but at the same time we are trying to convert this yes into bool and this yes into bool. So one costly column cannot store two types of data. It can store either string or boolean. Hence here if we are trying to convert yes into true, it is not working. It is still showing yes. It is not converting into true. Now let's learn about NA values. These are the list of default NA values. What is the significance of it? Significance is that if any one of the member of this list is there in the CSV file, then it will be converted into NaN. For example, this non belongs to this list. Hence, it will be converted into NaN. Similarly, this hash NA, this also belongs to this list. Hence, this also will be converted into NaN. Let's do the practical for the same. Here in sales.csv, if you see this hash NA, this is converted into NaN, right? Similarly, this none also belongs to that list only. Hence, this none will also be converted into NaN. But is there any way in which we can tell that any number which is not in the list to be converted into NaN? For example, 10 is not inside this, but I want 10 to be converted into NaN. Is it possible? Yes, it is possible. Let's see how. In NA values, if we mention 10, so it will convert all the 10 into NaN. Let's run it. Control enter. You see this 10 here in the CSV file is converted into NaN. Similarly, this quantity is also converted into NaN. No, I don't want to convert quantity 10 into NaN. Only product 10 into NaN should be converted. Means this should be converted into NaN. This 10 should not be converted into NaN. Then how to do that? In that case, we will pass dictionary into NA values. With the help of product key, we will pass what all needs to be converted into NaN. So in product column, I am mentioning convert 10 to NaN. So this 10 will be converted. Control enter. This 10 will be converted to NaN. Similarly, in quantity column, convert N1N and N2N into NaN. So in quantity column, this N1N is converted into NaN. Similarly, this N2N is also converted into NaN. And whatever by default values of NaN, that is hash NA and non, will also be converted into NaN. No, I don't want this default value to be converted into NaN, these two values. So how to do that? You just mention that default values need not to be converted into NaN. How will we do? You will keep default NA into false. Let's run it. When we are running it, you can see this non is not converted into NaN. Similarly, this hash NA is also not converted into NaN. Now what you want? You want to convert this N1N into NaN and N2N into NaN, but not these default values. So just to make sure that default values are not converted, you are making it false, right? Keep default NA into false. But you want to keep N1N and N2N into NaN. So you will pass it into this NaN parameter. Okay, this. So let's run it. Control enter. You can see N1N and N2N is converted into NaN. But this default hash NA and none is not converted. There is another parameter called NA filter. What does it do? It goes to every field and check if it belongs to NA values. If it belongs to NA values, and then it convert it into NaN. So this extra check is happening. So whenever we make it false, These checks are not happening. Hence the conversion of these values into an n is also not happening. Since those steps are not happening, reading becomes little fast and performance is increased. When we read sales.csv, it looks something like this. This leftmost column is not a column. This 0, 1, 2, 3, 4 and 5 is not a column. This is an index. It is used to filter rows. We will see how to filter rows in some other video. But for now, like if you want any other column to be indexed, not this default 0, 1, 2, 3. So how to do that? You need to pass that column in index column. Here you are passing the same. So you can see like this order become index. This is not looking like another column. Its height is little lower. So this is how index looks like. But it is possible to make two columns as an index. Yes, it is possible. For that, code looks something like this. In index column, you will be passing list of columns which you want to be indexed. So you want category and product to be indexed. So these to be on the leftmost thing, this category and product. So let me show you how it is made. Here is fruit.csv. So we have to shift category to the leftmost. So let's do that. And product to the second leftmost, right? So you can see category is leftmost and product is second leftmost. Now you can see inside fruit there is apple. Again inside fruit there is banana. So you can assume that this fruit is like a group. So you can group it, merge cells. Okay. Similarly, this vegetable, inside vegetable category, carrot is there. Again fruit category, orange is there. But again vegetable category is coming two times. So this is like a group. So you can merge it. So you can see like it is increasing readability little more. Like inside fruit you can see two products are there and their data. Again this vegetable, it has only one product. Again this fruit has only one product. But again vegetable comes, it has two products, 0 and 10. Same is happening here. I don't know it is making much sense for you or not. But to make you understand it more, let me show you another example. Here I am reading sales per month. The data looks something like this. Like on January, day 1, 1000 sales were happen. On January 2, day 2, 2000 sales happen. Similarly, January 4, 400 sales happen. Similarly, in February, on second day, 3000 sales happen. In this case, if you want like month and date to be indexed, so how will it look? Control enter to run. So you can see all the Januaries are merged together. So you can see in January all the sales whatever has happened. Similarly in February you can see all the sales what has happened, like on second day of February and third day of February, fourth day of February and fifth day of February. It increases the readability. Moving ahead, here I have defined one function. What this function do? The name of the function is add 500. This function takes one input, convert it into integer and add 500. Means whatever input it gets, it adds 500 into it and returns the same. Similarly, this is another function. What does this do? This takes an input and it converts it into lowercase. So let's use it in converter. Converter is a concept which is used to manipulate column data. So converter takes dictionary as an input. So in dictionary you can see keys are column names. This sales is a column name, this is another key month, this is a column name, and values are functions. So in sales column, perform the operation of add 500. So in sales column you see this is a sales column. So what it will do for every input, this is in CSV, if you see here in sales column, this is first input, it is 1000. So add 500 work is what? Add 500 into it. So here it is becoming 1500. Similarly, this is 2000 here in CSV if you see. So what this add 500 it will do? It will make 2500. That's what it is reflecting here. Again, now you see in month what the function you are passing lowercase. The lowercase convert the data into lowercase. So in month you see January is capital everywhere, right? J is capital and F is capital in February. But after running this same in Pandas, you will see J is small and F is also small in February. Same thing can be written in different way also. Instead of passing the function name, you can pass lambda function here. This function is also doing the same. This lambda function is taking one input x, converting it into integer and adding 500. So basically this is also adding 500 into the number, and this in month we are passing another lambda function. What it is doing, it is taking an input and convert the input into uppercase. So same thing happening, you see in month column everything is in capital, January in capital, JN, FEB in capital, so all the data in capital in month column. Similarly in sales everything is increased by 500. This data you can compare this with the CSV here. Skip rows is used to skip rows from the top. Here we are passing 2, it means skip first 2 rows. So what it will do, it will skip first 2 rows. So from the third row it will print, this is the third row. So January to 200 will become the header, and after that it will print all the rows. But in skip rows, instead of passing integer, you can pass function also like this. Here x is the index and this function will return true or false. So when the index is divisible by 2, it will return true or false. It means all the index which is divisible by true, skip those index. Index of this row is 0. This is divisible by 2. Hence delete this row. Similarly, index of this row is 1. This is not divisible by 2. Index of this row is 2. So 2 is divisible by 0. To skip that line. Index of this line is 3. 3 is not divisible by 2. So we will not do anything. This index is 4. 4 is divisible by 2, to skip that line. Similarly, it will skip all the alternate lines. And when we run this, we'll get something this kind of output. January 1 1000, which is equal to this. Similarly, January 3 500, which is equal to this. I hope how it works, it is clear to you. Let's undo this. Here is another parameter called skip footer. In this we are passing 1, means you skip the last line. So what it will do, it will skip this line. So when we are running this, you can see this line is not there. This line is there, but this line is not there in this data frame. When we make it to 2, what it will do, it will skip last 2 lines, means these 2 lines will be skipped, these 2 lines. So you can see the last line is February 3 1500. So which means these 2 lines are not there. Now what does this do? Nrows. Nrows print nrows after headers. Here we are passing 2, so it will print 2 rows after header. I hope it is clear. Skip blank lines. So let's assume if we delete few lines from here, delete, Ctrl S, and let's run this. You see these are blank line, wherever I am marking as X, this is blank line. So in place of blank line, it will print NaN, NaN, NaN. Similarly, here is blank line. In CSV, if you see wherever I am marking as X, this is a blank line. So that place also it is printing NaN in data frame. So if we make it true from false, so it will skip those lines. Control enter. You see all those blank lines are not getting printed. NaN is not getting printed. Sometimes data set is very huge and it is not possible to read the data. So what will we do? We will read the data in chunks so that we can read it and perform our analysis. The solution to read the data in chunks is iterator. What we are doing here? Here iterator is equal to true, and after reading it, we are storing it in reader. And reader works very well with the get chunks. So reader.getChunk, what it will do? it will print first two lines. So it will print these two lines. You run this reader.getChunk again. Here you are passing 3. What it will do? It will print next 3 lines. 1, 2 and 3. You are running this reader.getChunk with 2 again. What it will do? It will print next 2 lines. So similarly, you can read the data in chunks, perform the required operation and aggregate the result. Another way to work with chunk is chunk size. Here chunk size is equal to 2, which means in every chunk we will have 2 rows. So here we are iterating with the help of for loop and printing the chunk. So you can see every chunk has 2 rows. This is another chunk, it has also 2 rows. This chunk has also 2 rows. It has only 1 rows because the data is indented here, like more rows are not there in the data set only. That's why it has only 1 rows. If you don't want to use for loop, you can use iterator. Let me explain the concept of iterator and next then I will explain this code also. So let's suppose this is a chunk and each chunk stores 2 rows. Initially the iterator will point here and when you call next, what it will do? It will print this and move the iterator from here to here. You run next again. What it will do? It will print this 2 rows and move the iterator from here to here. You run next again. What it will do? It will print these 2 rows and move the iterator from here to here. I hope you understood. So similarly here also we are reading this and this is the iterator and this is next and we are passing that iterator here. What it will do? It will print first 2 rows of the chunk. When we run this again, what it will do? It will print next 2 rows, that is next chunk. You can compare it with the CSV data also. First 2 rows here and these 2 rows here are same and next 2 rows here and next 2 rows here are same. It is simple concept, try to understand. Before we go ahead, I want you to go some time back in the video and revise what is a separator. Now in this CSV, you see this month, this date and this salary is a header. And January comes under month, one comes under date, which means 1st January, and this $1,000.51 come under sales. Similarly, this January comes under month, this second means 2nd January comes under date and $2,000 comes under sales. But when we read this code.csv, you see the output is not as our expectation. This month is becoming index, whatever date is there, that is becoming month, and sales is splitting into 2 parts. And before comma, whatever is there, star 1 is becoming date and after comma is becoming sales. You see. So what is happening here? Pandas is treating this comma as a field separator and separating the columns. But we don't want this to happen. So what we will do? We'll tell Pandas that if the comma is included between 2 stars, then don't treat it as a separator. Print it as it is. So how to achieve that? Just mention quote char and whatever the character is quoting the separator, you need to mention. Here in our case it is star. So star here mentioned. Let's run it, control enter. You see the data become as our expectation. This whole thing is coming under sales and these stars are also excluded. Let's check the information of this dot info, control enter. Here you will notice that the data type of sales column is object. But why it is object? Ideally it should be float because this is a number. It is object because Pandas is not able to interpret it as a int or float due to this comma. So we need to tell Pandas that this comma is a 1000 separator. So let's do that. 1000 is equal to comma. At the same time we know quote carries star. When we run it, you see those commas are excluded from the data And when we check the information, you will notice that the cells became float. Let's try the dot. Here you see data type of cells is float. So since it became float, you can perform mathematical operation on this column. When it was a string, you was not able to do this. Here in the highlighted line, you can see there are too many commas, which means it is a bad line or defaulty line. So how to handle this situation? To handle the same, there is one parameter called on bad lines. So when you pass skip in this parameter, what will happen? Let's do control enter. It will not read this defaulty line or bad line. It will skip this line and it will read other data, means other rows. No, I want to show warning when there is any defaulty line and also skip this line while reading the data. Okay, that can be done by passing here warn. Control enter. You see it is showing an warning and bad line is not printing here. No, don't show data only, show the error instead of warning. Okay, that can also be done with the help of this error value. Control enter. Now you will get error and you will not get any data. Here in this data you can see there are some comments and you will notice that all the comment is starting with forward slash. So when you read this data, what will happen? You can see these comments are also printing. In index number 2 and index number 5, these comments are printing. I don't want these comments to print. So how to handle this? You just want to tell pandas that ignore the line which are starting with forward slash. Fine, we can do the same. Here in comment parameter, when we are passing forward slash, we are saying the same to pandas. Let's run this. When we run this, all the comments are removed from this data frame. Encoding is the process of converting human language into machine language, that is binary or 0 and 1. For encoding, there are different types of algorithm. Some of the famous examples are ASCII and UTF-8. ASCII is famous for converting English language into machine language. Similarly, UTF-8 has capacity to convert Hindi, English and many more languages into machine language. Here in this example, you can see the highlighted part is Hindi. So when we try to read this Hindi word with the help of ASCII algorithm, will it work? No, it will not work because ASCII cannot read Hindi language. So let's try the same. When we are running this, you can see we are getting an error. Similarly, when we change to UTF-8, when we run it, you can see it is able to read this Hindi word also. By default, the encoding algorithm is UTF-8 and it supports many different types of languages, so you will have very less chance to change it. Here in this data, you can see before January, there are some initial space and in the next line also, here are some initial spaces. So when we are reading this data with skip initial space as true, what it will do? It will skip these spaces. But when we are reading this as skip initial space as false, what it will do? It will not remove these extra spaces. So let's do the practical. When we are reading this data and storing it into df4, here df4, and this df4 we are exporting into one csv file whose name is skip.csv. So let's see how this skip.csv looks like. You see here the spaces are skipped before January and here also. Similarly, in df5 we are storing the data with skip initial space as false, means it will not remove the initial spaces, and df5 we are exporting it to a csv file which name is skip.csv. So let's see how does it look like. Skip.csv I have opened here. So these spaces are not skipped. Why are we exporting into some csv? Because when we print the df4, so it will be difficult to monitor how many initial spaces are there. That's why I have exported to one csv file, so that it is easy for me to explain and for you to visualize initial spaces. Here in this line you see this line is too long because of these parameters like delimiter, quote char, skip initial space, escape char. So there are many parameters we are defining here. So is there any way to shorten this line? Yes, you can reduce this line to this small with the help of dialect. So my dialect, we are passing in dialect. So we need to define somewhere my dialect also. So here we are defining my dialect with the help of csv dot register dialect. This is the name of the dialect which we are defining, and these are the list of parameter and its values which we want it to store. So whenever we pass my dialect while reading csv like this here, so it will refer these parameters like delimiter will be pipe, quote char will be double quotes, skip initial line will be false. So you don't have to mention those things here while reading here, because you are mentioning everything in dialect. At the same time, like you have any similar data like sample data.csv, so there also you can reuse this my dialect. But there is one restriction: not all the parameters you can define in dialect. There are some limited parameters which you can define in dialects. You can explore this in the documentation like delimiter, double quote, escape char, etc are there which you can define in dialect. But there are many other parameters also which you cannot define in dialect. So keep it in mind. Now I want you to introduce you to memory map. This is one of the parameter which helps in increasing the reading speed. It takes boolean input. Whenever its value is true, it reduces the extra IO operation. Whenever its value is false, reading speed is little slower. Now moving ahead, here if you see when reading sales.csv, it is printing first 5 line of the data and last 5 line of the data, and in between it is printing dot 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 dot. So is there any possibility to see all the lines? Yes, it is by setting display.max row to greater than the number of rows available in your csv. Let's suppose there are total 33-34 lines in your csv. So if you set it to 50, control enter, now when we read sales.csv, what will happen? It will read all the lines, because 33 or 34 lines are less than 50 lines, hence it is able to read all the lines. Internally, pandas process the data into chunks, but there is one drawback. Let's suppose this data is read in 3 chunks: first chunk, second chunk, and third chunk. When you are reading first chunk, pandas will assume the data type of this cells is int. Similarly, when you are reading second chunk, it will assume that data type of cells is int. But while reading third chunk, the data type will be string. Hence, there is inconsistency in the data type of cells. To solve this problem, we need to read complete data frame at once so that Panda is not getting confused. How to do that? We can do that by making low memory equal to false. What it will do? It will force the pandas to read complete file in one data frame. Let's suppose you don't want to use low memory. Is there any other solution in which you can tell pandas no, treat this column as XYZ data type? For example, sales as a string data type only. Yes, it is possible. If you don't want to use low memory, you just use dtype and mention that sales column data type is string. When you run it, you can check sales column data type is string. I know it was very tough to understand this video because of large information is packed in this small video. So I want you to revise the concept of list and dictionary if you are finding it tough to understand, and watch this video again. And feel free to ask your questions in comment. I'll make sure to answer.